Lucita is actually three portions. There is a northern portion, which is the Panuco area, and that's had historic drilling on it. There's a southern zone just to the east of the main part of San Nicasio that's really important to the Veta Grande system and some intermediate veins between there and the Lucita central zone. And Lucita Central, which is the zone that we're talking about, has what we are referring to as the Palenque vein system. That's the name of the main vein that's been historically mined, but very shallowly. The outcropping portion of the Palenque vein system in the central Lucita area is around 4 kilometers in length. The purpose of this drill program, as the Maiden drill program into the Palenque vein system, was to step along the vein system and to test what does the vein look like at depth, because it had never been drilled before. We started in the central portion of Palenque because this had the most obvious workings, it had the best sense at surface. And in the past news release, we put out results from Palenque Central, which is here near 2101, 2105. 2105 had very good results. And this is an area where there has been some historic mining. And so we started to learn about the system here. And as we move west, we really liked the far western part of this area because the surface indications were encouraging. There was lots of mineralized float at surface. There was a more than 13-meter bricked in shaft. Just the rocks at surface looked more altered and more mineralized. And historically, there was an encouraging assay from some of the surface waste material. One of the things that's interesting, there are some places where there's more quartz at surface than there is calcite, and quartz tends to be a deeper level mineral than the calcite. So you would typically find quartz associated with the sulfides of interest. It's structurally controlled. Why you just have not a random change here from orange to blue. There are structures in here that have offset to them. And there's some grade at surface along these quartz portions, but sometimes when we drill them, it's not that great. But the places where the calcite is outcropping, it seems like sometimes it's actually the better mineralization at depth. One of our current theories about this is that the places where you see calcite at surface, sometimes the width of the vein at surface is wider, and that perhaps these are structures that had better fluid flow through them, and they seem to be associated with better grade at depth. So we honed in on this area, drilled underneath the calcite rich portion at surface here. At surface, the vein it's mostly barren. The style of minerals and the type of minerals there are interesting in terms of indicating that there may be something else at depth. Some of the step outs are quite large between the zones. For instance, between hole 6 and 7 and hole 8 is a distance of approximately 800 meters. And between hole 8 and hole 9 and 10 is 375 meters. In areas where we had better confidence and understood the rocks a bit better and were getting interesting intercepts in the drilling visually, we drilled closer. So for instance, in the area between hole 10 and hole 12 is 300 meters. And so we stepped along here to collect structural measurements and to understand where are the structures and what is controlling the grade. And that's something that we're still working through to begin to model that up and to understand, for instance, in the area near hole 6 and 7, what is the structural complexity that caused the vein to be present at surface, but not where we predicted at depth. And that indicates that there's a structural offset in this zone that we are working on modeling so that we can have more accurate targets to come back and follow up in this zone later. When we drilled hole 9, 10, we were targeting all of these steep veins that you can see at surface. There's clear surface workings because at surface, the vein has a better expression, it has a better shaft, and the material that's scattered everywhere at surface is more altered, has sulfides, has better mineralization. The historic assay from Pan American was also a better grade sample. So the upper package is a volcanosedimentary package that we see. It outcrops quite a lot in the Lucita area, also in San Nicasio. This is Chilitos Formation, the main rock formation that outcrops in the district. Variably, there's lava flows and airfall tuffs and some sediments. And I think it's interesting that where the steep veins and sort of another shallow vein that has some interesting lithology with it. The rock that is associated with this shallower structure here is associated with mineralization other places in the district. There's a confluence of things here, a number of different vein orientations and a structure, and the structure is well mineralized. So we drilled hole 9 first, and actually the grade in these structures was better in hole 9. And we thought that we were through the system. The hole was ended. The rocks didn't look particularly spectacular in the dark and at the rig, but once we got them to the core shack and had a closer look and started XRFing them as we were logging, things started to look really encouraging. And so we decided to follow up in this zone with DDLU 2210 to test this area again farther to the east, as well as continue to drill the hole deeper. And as we were drilling that hole, we continued to intercept those shallower, steep veins. And then the thing that was unexpected was that we drilled a really interesting zone here near this fault contact. That's a flat-lying contact. The veins themselves are quite steep to somewhat inclined, but this is an almost flat and slightly north-dipping structural contact. And in fact, that was one of the main zones of mineralization in this hole. If it outcrops at surface, we have yet to identify it. It's blind from surface. It's not obvious at surface. It's not what we anticipated to drill here. We anticipated to drill the steep veins, which we did. The highest grade result in hole 10 was actually at that faulted contact. It was a 737 grams per ton silver. To me, this is so interesting. The whole zone of mineralization is just shy of 50 meters at just shy of 60 grams silver. That's a large interval of low grade mineralization. And it's not something that we've necessarily seen before in the property or in this part of the district. And so we drilled through this volcano-sedimentary package through a shear zone, a faulted zone that actually you can see that it has had movement along that structure. But there's also, we believe, deeper in the stratigraphy, there are more sediments, including these black shales that we drilled at depth here. And the good thing about black shales, just generally, is that black shales often tend to be very reactive to sulfides. They love sulfides. There's lots of carbon in the rock. They are good hosts to mineralization in many different types of deposits. And the thing that is really interesting about this zone in the black shales is that the mineralization continues into the shale. And when you look at the rock, it mostly just looks like a shale with teeny tiny millimeter scale veinlets in it. And most of the veinlets are barren, but some of the veinlets have fine sulfides in them. And just the tiny amount of veining that we saw in these samples produced significant grade. So to me, the fact that this style of mineralization is not something that has previously been recognized in Syria, but that we have located, to me, that's really encouraging, because if you have even a centimeter wide veinlet array as opposed to millimeter scale veinlet arrays, you're going to have bonanza grade with this type of mineralization. And so to me, this is a really interesting exploration target, not only in the flat-lying structure, which will be a flat-lying sheet that continues laterally and in sort of all directions, but also that you have veinlets that must be carrying substantial grade because they're so fine and not very dense in the places that we get zones with grade here in the black shale. So sort of the question is, where are there more of these veinlets, or where are the veinlets slightly wider? And one of the things that we're doing now is trying to identify which of the veinlets are carrying the grade and get structural measurements on those so that we can model them up and follow the trend of those veinlets to see, where do they intersect with larger structures and what is their orientation so that we can target them more accurately. And at the end of the program, we had enough information from what we had learned from the first 5 holes that we wanted to come back and do another step out along the vein somewhat to the east, trying to understand the structure and some of that complexity there. And so we drilled hole 2213 to the east of hole 4 and 5 in the central portion of the Palenque system. That hole definitely intercepted zones of substantial grade up to 843 grams per ton silver. The zones were narrow, and we believe that this time that is because of the angle of the hole and the angles of the vein, as well as the level at which we drilled the system. And so we are collecting structural data in this zone and working to model up this area so that we can come back and target the zones of high grade more accurately.